Okay, let's look at an example now of capacitance. So let's say I have here something like a simple, what let's call a paper capacitor, which usually consists of a couple of sheets of foil. Now inside a real capacitor, these sheets of foil would be separated usually with an insulator like a sheet of paper between them. But let's assume that we just have some rectangular sheets of foil. Each sheet has a width and a length and is separated by a distance d. And so let's say that the width is about, let's say, an inch, 2 centimeters, and the length of each sheet in the capacitor when it's rolled out is, let's say, 2 meters, and the separation distance is 0.01 millimeters. And now what we can do is start by, let's calculate what the capacitance of this sheet of foil would be, and also what the maximum operating voltage would be if the sheets are separated by, let's say, air. So the capacitance is going to just depend on the geometry of the capacitor, and this was an expression that's derived in class, and this is epsilon 0, which is a constant, times A divided by the separation distance d. Now epsilon 0 again is a constant. This is 8.85 times 10 to the minus 12. The area will be the length times the width. So let's just plug in those numbers. That's 0.020. That is the width, and then the length is 2.0. And then we're going to divide by the separation distance d, which is 0.01 millimeters. So that's 0.01 times 10 to the negative third, or that's 1 times 10 to the negative fifth meters. So we'll have here 1.0 times 10 to the negative fifth. And if we plug all this in, we'll get the value for the capacitance, which is 3.5 times 10 to the minus eighth. And remember, this is farads, or we could also say that this is 35, let's say, nanofarads. But 3.5 times 10 to the minus eighth farads. Now, if we assume that the plates are separated by just air, then what is the maximum operating voltage? Now here we have to consider what's called the dielectric strength of air, or basically the maximum electric field that we can have in between the plates before electric breakdown occurs and sparks start to jump across the plates. So I'm just going to call that for the time being Emax. We'll come back to this, I think, later in the chapter. Now for air, this maximum electric field for air is 3 million volts per meter. It's just 3 times 10 to the sixth, and that's volts per meter. And again, we have a distance here of 1 times 10 to the minus 5 volts. So we can see that the maximum operating voltage would be, in this case, about 30 volts. Now, given that, so the maximum voltage we can put across this capacitor and still have it be a capacitor is 30 volts. We know what the capacitance is. It's 3.5 times 10 to the minus 8th farads. Let's calculate what is the maximum amount of charge we can store on the capacitor. And that would just be given by the capacitance, which is a constant, times the maximum voltage that we can have. So this is 3.5 times 10 to the minus 8th, and the maximum voltage we can have is 30. And so that gives us about 1.0 or 1.1 times 10 to the minus 6th. Let's call it 1, we'll just round it down, times 10 to the minus 6th, and that's coulombs, or that's about 1 microcoulomb, which is, by the way, an awful lot of charge. Now, what is the maximum, how much energy can we store in this capacitor? Now remember, in this case, there are several different ways that you can calculate this if you know the charge and the capacitance, or if you know the capacitance and the voltage. So let's just use, let's say, 1/2 times the capacitance times the voltage. So this is 1/2. The capacitance was 3.5 times 10 to the minus 8th. Let's indicate here we're trying to find the maximum, and the maximum voltage that we can have is 30. Wait a minute, this is CV squared. So this is 1/2 times 3.5 times 10 to the minus 8th times 30 squared. 10 to the minus 8th times 30 squared, and we get about 1.6 times 10 to the minus 5th joules, or this is also about 16, let's say, microjoules. So we have, really, just starting from the dimensions of the capacitor, if we assume that it's separated by air, you see we can then go through and pretty much calculate the parameters of the capacitor, what its maximum operating voltage will be, how much charge we can store on it, and how much energy we can store really in between the plates of the capacitor.